Hi guys, and welcome to my channel. In this video, you are going to learn about operators in programming. So what are operators? Operators are characters, meaning symbols that we use in order to perform different operations. For example, if you want to add two numbers, you use plus operator. If you want to subtract them, you use minus operator, and so on. So there are many different operators and different types of operators in programming. And in this video, we are going to cover arithmetic operators, assignment operators, increment, decrement, and we are also going to learn about some of very sneaky and very important bugs and errors that happen to beginners, but also to some more experienced developers. So I'm going to explain everything that you need to know about this topic. And before we continue with this video, there is something very important that I want to tell you. So if you want to learn practical programming and you want to start creating real applications as fast as possible, and you want to get a job as a software developer, then you should definitely join my practical programming course. I have created an entire plan for you. Everything is step by step, all of the lessons that you need to watch, all of the exercises that you need to do, everything is on one place, and the only thing that you need to do is to follow that plan that I have created. If you're a beginner, there are a lot of things that you need to learn, a lot of exercises that you need to do, but if you start today and follow the plan that I have created, in 6 months, you will be prepared to start a successful career as a software developer. As a programmer, you will have the option to work anytime you want, any place you want. So you will be able to work on a beach, by the pool, on a mountain. Also, you will get the opportunity to meet some great people, and you will be able to work on great projects that are shaping our future. And all of that while earning a lot of money. So if this sounds like something that is interesting to you, then click the link in the description because I have made an entire plan that you need to follow until you achieve this. And there is even a special discount that you can get. So more details are going to be in the description. And now let's continue with the topic of today's video. So let's first talk about arithmetic operators. There are 5 arithmetic operators. Those are plus, used to add numbers, and then minus, which we use to subtract numbers, and then we have division operator, multiplication operator, and then we have this operator here, which is called modulo, and we are going to see how this one is used later. Okay, so let me put this here like this. So arithmetic operators, and then we have these 5. So now let's see how each one of these 5 is used. Let's start with plus operator. So how do you use it? As we already explained, it is used to add two numbers. For example, I can say int result is equal to, let's say 13 plus 12. So this here is plus operator, and it is used to add these two numbers. So if I print this result variable here, we should get 25. So let's check that. Okay, as you can see, 13 plus 12 is equal to 25. So that is how you use plus operator. Now, this plus operator has another interesting use, and that is concatenation. For example, what I can do is I can say result is equal to, and then I can say here plus, and then this variable. So in this case, because I'm using this plus operator with a number and a string, what this plus operator will do is it will just concatenate those two together because it does not make sense to add a number and a text. So what it will do is this. So now we have result is equal to, and then it simply adds this result. So that is another usage of this plus operator. Now let's see what are some common errors that can happen. For example, what is going to happen if I say 13.5 plus 12.3? As you can see, immediately we get this red squiggly and it says cannot implicitly convert type double to int. The reason is because here we are trying to add decimal numbers, but we are trying to store that result into an integer variable, and that cannot be done. So even if I do something like this, 13.5 plus 12.5, the result is going to be an integer number, but we still cannot do this. So if you want to perform operations on decimal numbers, you need to use correct data type. In this case, that can be double. So as you can see, now we don't have error anymore. If we are working with decimal numbers, then we should use decimal data type, which means float, double, or decimal, in order to store the result of that operation. And if you don't know about data types, then please watch this video. There I explained all of the important data types that you need to know about, and it will also be linked in the description. So now if I run this program, we get 26, which is the correct result of this operation. So that is how you use plus operator. Minus operator is very similar. So if I say 13.5 minus 12.5, and I run this program, as you can see, we get 1, which is the correct result. But what do you expect to happen if I do something like this? If I say, for example, 13.5 minus 12.3. So what do you expect to get as a result of this operation? Let's find out. Let's run this program. And as you can see, we get this result here. So we get 1.1999999 and so on. But as you already know from the regular mathematics, the result should be 1.2. So now the question is, why do we get this number here? It's very weird. Well, the answer to that question is because you have learned mathematics wrong. And this here is the correct result. I'm just kidding. That's not the reason. Here is the explanation of why are we getting this result. As you already know, everything that your computer does, it does that in binary numbers. So only ones and zeros. Now, some decimal numbers are extremely hard to represent in binary format. Examples of those numbers are 13.5, 12.3, and 1.2, and many other numbers as well. So just to demonstrate that, let me find a binary calculator on the internet, and then I'm going to show you what I'm talking about. So here is a binary calculator, and what I want to do is I want to try and convert 1.2 into binary number, because that is what your computer works with. So if I say convert, this is the number that we are going to get. This is 1.2 in binary format. It has 21 digits, whereas in decimal format, we need only 2 digits to represent this number. So let's copy this number, okay? And then I'm going to delete this, and let's try to convert it back. So from binary to decimal. So this is the result that your computer got, and now it is trying to show it to you because you understand decimal. So this is what you will see. So this is not 1.2. This is as close as your computer can get to 1.2. And for that, it is already using 21 digits. So if you want even higher precision, if you want to get even closer to 1.2, what you can do is here you can add more digits. So if I say convert, we get even closer. And then I can add even more digits. And this will take us even closer to 1.2. So if you really want to represent 1.2, then you would have infinite number of digits in binary format that you need in order to represent that number. And it is really not possible to store infinite number of digits in any variable. So the only thing that your computer can do is it can get as close as possible, which is this number here, or this number here, or this number here, and so on. But the more digits that you take, the more memory you are taking. So I would say that this number here is close enough. So now that you understand why this is happening, let's see how we can show this number in a format that is normal and understandable for us humans, because we don't really want to see 16 or 20 digits. We simply want to see 2 digits. That's what we are working with most of the time. So what you can do is here for this result that you get is you can use math.round. This is a function that will round the number that you give to that function to as many decimals as you want. And here I will say, please round it to 2 decimals or even 1 decimal. So if I run this code, as you can see, now we get the normal result, the one that we expect and the one that is understandable and natural for us. So that is how you use minus operator. Now let's talk about division operator. Division operator is very interesting and it's also very tricky. So let's delete this and let's simply say result. And here I will say, for example, 15 divided by 5. So if I run this, the result that we are getting is 3, which is the correct result. Nothing wrong here. But let's stop the program and let me show you something else. If we say, for example, 15 divided by 6, what do you expect to get? Let's see. And we get the result of 2, but we know that the result is not 2, it is 2.5. So why are we getting 2 here as the result? Well, something interesting is happening here. I believe that most beginners would first check if this variable here has the correct type, because if this variable here was an integer variable, it would be understandable why we are getting this error. But this variable here is of type double, so we still have a question, why is this here 2 and not 2.5? Well, the answer is very interesting. If you are dividing two integers or performing any operations on two integers, the result of that operation is going to be an integer. But if one of these two is a decimal number, like this, for example, then the result will be of more precise type, which means this here is integer, this here is double, so the result will be double. The same would be if you did something like this, or if both of these were decimal numbers. So the result will be of more precise type. And if both are int, then result will also be int. So in this case, or in this case, or even in this case, we are going to get the correct result. But in this case, we will not get correct result. So let me prove that. If I start the program, as you can see, now we get 2.5, which is the correct result. Okay, so what is the general rule that you should remember here? Whenever you are dividing two numbers, even if they are integers like 5 and 2, for example, the result still can be decimal numbers. So you should keep two things in mind. The first thing is that resulting variable should be of decimal, float, or double type. So some data type that can store decimal numbers. That is the first thing. And the second thing is that one of those two numbers, one of those two operands should be with decimal point as well, like we have here. So instead of 15 and 6, we have 15 and 6.0. Okay, so those are two very important things to keep in mind to avoid any errors that can happen. Now, there are some more interesting things when it comes to this division operator, and that is, for example, this. So what do you expect to happen if I say this? 15 divided by 0. What is going to be the result of this operation? As you can see, immediately our compiler gives us this little red squiggly and it says division by 0. That is forbidden, and this does not have anything to do with computers and programming. This is just mathematics. So in mathematics, dividing by 0 is forbidden. So in computers and computing and programming, it is forbidden as well. But there are ways to trick your computer and to still make it divide by 0. So let me show you that. So instead of doing it directly like this, what I can do is I can say, for example, double number 1 is equal to 15. Okay, and then double number 2 is equal to 0. So then what I can do is I can say number 1 divided by number 2. So now your computer does not really know which numbers you are dividing, so it cannot give you that red squiggly, but you will get an error in runtime. So when I run my application, as you can see, result is, and then question mark. I have no idea what the result is, again, because it is forbidden to divide by 0. And in your computer, you maybe get that little infinity symbol, and that is absolutely the same. It's just a way for your computer to tell you, hey, I have absolutely no idea how to divide these two numbers because it is forbidden to divide by 0. So always remember that when you are using this division operator. So let's talk about the next operator, and that is multiplication operator. I am going to delete all of this code. We don't need it. Multiplication operator is very simple. So 12 multiplied by 13, and we get a simple result, nothing really special here. So 156. And if you want to multiply decimal numbers, 12.4 multiplied by 13. Again, the result needs to be of type float or double or decimal, so you cannot store the result of this in an integer variable. That is just one important thing to keep in mind. But if I run this, we get the result that we want. And again, because it is very hard to represent decimal numbers in binary format, we still have this little precision error. But if you want to represent this in a format that is understandable to us humans without this many decimals, what you can do is, again, you can say math.round, and then this result that you want to round, you put that inside parentheses, and then you say how many decimals you want to have. If you say, for example, 2 or 1 decimal, that is going to be the format that is understandable to us humans, and then you are going to get the correct result. Okay, now let's talk about this operator here. It looks like percentage symbol, but it is called modulo operator, and in real life it's not used that much, but in programming it is used very, very often. So this modulo operator is used to give you the remainder after you divide two integer numbers. So when you divide two integers, what remains after that division? So let's delete this. Let's return just result like we had previously. And here I'm going to say int result because we are dividing two integer numbers. So the result is also going to be integer. And to demonstrate this, let's say, for example, 10 modulated by 3. So what this here means is, let's say that you have 10 apples and you want to divide them equally among your 3 friends. So how many apples will remain? That is the result of this modulo operation. So if I run this, as you can see, result is going to be 1. So if you have 10 apples, you divide them equally among your 3 friends. What remains is 1 apple, and that will be the result of this operation. Okay, let's stop my program. Now, when is this modulo operator used? Because I said that in programming it is used very often, but in real life not so much. So the situation when you use this modulo operator most often is to check if a number is even or odd. How do you do that? Well, if you divide any even number with 2, the remainder is going to be 0. But if you divide any odd or uneven number with 2, the remainder is going to be 1. So by using this modulo operator, you can easily check if the number that you are working with is even or odd. And this is used in many different calculations, formulas, and so on. So just to prove this, if I run my program, here we get the result of 1, which means that 5 is an odd number. But if I put an even number here, for example, 6, and I run my program, we are going to get the result of 0, which means that 6 is an even number. Okay, so with this, we have covered all of the arithmetic operators. And now let's talk about something very important, and that is operator priority. So what is going to be the result of this? 3 plus 9 divided by 3. What is going to be the result of this operation? Let me know down in the comments. So if I run the program, the result is going to be 6. So let's explain why is the result 6. Well, this operator here, division operator, is older, meaning it has priority. It is executed first, and then we execute this plus operator. So the calculation goes like this. 9 divided by 3, the result of that is 3, and then we add 3 to that. So that is the correct order. That is the correct priority, and not 3 plus 9 is equal to 12, and then divided by 3. So that is how some people will get the result of 4, but 4 is not correct result. So we first perform this operation and then this operation here, the same as in mathematics. So that is when it comes to operator priority. These 3 operators have priority over these 2 operators here. So now I have a question for you, and that is following. What will be the result of this operation? 5 plus 7 modulated by 3. Let me know down in the comments. Okay, so if I run the program, as you can see, the result is 6. And the reason for that is because we first performed this operation. So 7 modulated by 3 is 1, and then we add 5 more, so that is 6. Now, if you want to change priority of these 2, you would do it the same way as in mathematics. So you can simply put these 2 inside parentheses, which means, hey, do this part first. This here results in 1 number, and then modulate that by 3. So now let me know what is going to be the result in the comments. If I run it, as you can see, we get a different result because 5 plus 7 is 12. And when we modulate that by 3, we get 0 because 12 divided by 3 is 4 and we have 0 remainder. Okay, so with that, we have covered everything about arithmetic operators. So now let's talk about another interesting type of operator. And that is this operator here. You have seen it this entire time, but maybe you did not think about this as an operator as well, but it is, and it is called assignment operator. So let's put it here. Let's say assignment. So assignment operator, and that is this operator here. So assignment operator is used to assign values to variables. Like here, for example. So here we are saying, hey, perform this entire calculation, and then you are going to assign the result of that to this variable here. So whatever this here results in, that will be assigned to our variable. Okay, so with this being said, you can conclude that this assignment operator has the smallest, the least priority, which means that all of these operations on the right side will be performed first, and then once you get one result, just one value, then this assignment operator will assign that to our variable. So it has the least priority. Now, there are some more interesting things that I want to show you. Some things that really make sense in programming, and programmers use them very often, but they absolutely don't make sense in real life and in mathematics. One of those things is the following. In programming, you can say int result is equal to 5, okay? And then you can say result is equal to result plus 1. For example, now this formula here does not make any sense, not at all, in mathematics. And this would be forbidden in mathematics, but in programming, it really makes sense. So what this here does is it simply says, hey, perform this calculation here, this operation, and once that is performed, assign that, again, to the same variable. So now if I run this code, what do you expect to get? So we get 6 as a result. We started with 5, and then we simply said, hey, add 1 to that and assign it to the same variable, and then print the result. So we get the result of 6. And this makes perfect sense in programming. In mathematics, not at all, but in programming, it's used very, very often. So the same way you can do this for plus operation, you can also do it for minus operation, and then division, multiplication, or modulo. Just make sure that when you are dividing two numbers or multiplying two numbers, or if you're working with decimal numbers, the type also needs to be float or decimal or double. So some type that can store a decimal point number. Okay, now let's return to this example here. I had this situation. Result is equal to result plus 1. Now, because programmers are extremely lazy, they found even shorter way to write this same thing, and that is like this. So they would simply say result plus equals to 1. And it does absolutely the same thing. If I start the program, as you can see, again, we get the result of 6. So now your question might be, Saldina, why would anyone use this weird looking formula here? Why don't you simply write result equals to result plus 1? Well, again, programmers are extremely lazy, and I was wondering the same question when I started learning programming, but then 7 days, 10 days, a month in, I was using this same approach here, and probably it's going to be the same thing with you. So if you continue programming, please come back to this video 1 month from now and then tell me if this here is better, or if it is better to write result equals to result plus 1 and so on. So I prefer this option here. Okay. And this operator here is another assignment operator that performs both adding operation and assigning operation. So whatever is on this right side, it will add that and assign it to this result here. So I'm going to add here plus equals. Now, the same way that we have plus equals, we also have minus equals, and then we have divide equals and multiply equals as well. And as you might guessed it, result minus equals 1 will simply subtract 1 from this result here. So if I run the program, as you can see, we get 4. Okay. And then if I say, for example, result multiplied equals by 2, and I run the program, as you can see, we get the result of 10. And then if I say result divides equals 2, what do you expect to get? Let's see. We get the result of 2. So can you remember those two important rules that we were talking about when we were talking about dividing numbers? Well, we said that the variable needs to be of type double, so something that can store a decimal point number. So now if I run this code, we get the result of 2.5. Another important rule was that at least one of the two operands needs to be of type double as well. And in this case, it is, because one operand is result, it is of type double, and then another operand is 2, and that is integer. So at least one is of type double. So that is the reason why we are getting correct result here. Okay, and then also not to forget, here we have modulo equals as well. So these are assignment operators, and they are just a shorter way to write these arithmetic operators plus assignment operation as well. Now let's see more things that programmers do because we are lazy. I'm going to show you increment and decrement operators. So let's put those here. We have increment and decrement. So increment is plus plus, and then decrement is minus minus. So how these two work? Well, here we have a variable called result. So what I can do is I can simply say result plus plus. And then if I print result, let's see what are we going to get. So we are going to get 6, because what this increment operator does, it simply increases this variable by 1. And then if I say result minus minus, that decreases this value here by 1. So now I will get the value of 4. So those are increment and decrement operators, plus plus and minus minus. Plus plus to increase the value by 1 and minus minus to decrease the value by 1. So now your question might be, Saldina, why? Why are programmers so lazy? Why do you have to have an entire operator just to increment value by 1 or decrement it by 1? Why do you need all of that? I'm sorry, I did not invent this, but it is pretty useful, I have to say. Why? Well, because now what you can do is instead of writing this, an entire line of code, you can simply say this. So in the same line of code, you perform some operation. Okay, so now if I run the program, what do you expect to get? Let's check. Something weird is going on here. We still get the result of 5, but we have decremented this variable. Shouldn't it be 4? Well, there is something tricky going on here, and that is the difference between this, which is called post-decrement, and this here, which is called pre-decrement. So what is the difference? Well, it has to do with priority of execution. This here will be executed first, and then it will print this entire value. But in this situation, we will first print this value, and then we are going to post-decrement, which means that in this situation, if I run the program, I get the value of 5, but if I copy this line of code one more time and I remove this decrement operator and I run my program again, as you can see, in the first line we get 5 and then we get 4. The reason for that is because we first print this and then we decrement. So when we print for the second time, we get this value of 4. So that is the difference between post-decrement and pre-decrement. Okay, and then the same applies for pre-increment and then post-increment. Okay, so that is how increment and decrement operators work. They simply increase the value by 1 or decrease the value by 1, and then depending on where you put them, if you put them after the variable, they have smaller priority, and if you put them before the variable, they have bigger priority, which means that they will be either be executed before or after you do whatever you want to do with that variable. Now, a tip that I would give you and something that is practiced in programming is that these increment and decrement operators are most commonly used with integer variables. As you could see, it can still work with decimal numbers, but most often it is used with integer variables. And just to make sure that you avoid any precision errors that I already demonstrated, the ones where we have a lot of decimals, make sure that you are using these operators with integer numbers. So both pre-increment and pre-decrement, as well as post-increment and post-decrement. So to avoid any precision errors or computation mistakes like I demonstrated previously, make sure to use them with integer numbers. Also, these increment and decrement operators can be performed only on variables. You cannot say 5 plus plus or 5 minus minus. These don't work with constants. As you can see, we get this red squiggly. Okay, so increment and decrement operations can be used only with variables, not with number constants, like I have demonstrated here. So now I want to talk about another very important topic and very sneaky bug that happens to a lot of beginners and also to some experienced developers, and that is overflow and underflow. So what are overflow and underflow? Let me explain. Let's create a variable here and let's call it int max, and inside this variable what I want to store is going to be maximum value of an integer number. So this here will give us the maximum integer number that can be stored inside this variable here. The same way we have int min. So here I can say, please give me the minimum value, the smallest value that an integer can have and that I can store inside this variable here. So now let's print these two. Let's say int max is equal to, and let's print this variable. Okay, and then let's also say int min is equal to, and let's print the other variable. So int min. So now if I run this program, as you can see, int max is this value, and then int min is this value. I'm not going to try to read either one, but it's 2 billion and something. Okay, so what is going to happen if I do something like this? If I say, hey, please pre-increment this int max, so increment it and then write it. Or if I say something like this, hey, please pre-decrement this minimum value, what do you expect to get? I don't know. Let's run the program. Okay, and something very weird is going on here. So for int max, we get this really small number. And then for int min, we get this really big number. This does not make sense. So why are we getting these two values? The answer is underflow and overflow. So here, we previously had the biggest value that an integer can hold, and then we added one more to that. So the behavior is like a clock. You go from 1, 2, 3, 4, 5, and so on until you come to 12. That is the biggest value. And then if you add one more to that, it will simply overflow and go to 1 again. So that is exactly what happened in this situation. And then in this situation here, we had the biggest value and then we added one more to that. So it simply went to the smallest value. And then here we had the smallest value and we tried to decrease that by 1. So it went to the biggest value, just like clock and clock in reversed order. So that is what overflow and underflow are. And this here is not the only way to get these overflow and underflow errors. These are very sneaky bugs that you can get in many different situations. For example, if you are trying to add two numbers that are very big, the result is going to be even bigger, so that can overflow. Or if you're trying to multiply two numbers, it's even easier to get an overflow. Or if you are trying to subtract two numbers that are very small, so very big negative numbers, the result of that is going to be even smaller, so that can underflow and so on. So you should be very, very careful in these situations, because these types of bugs, your compiler is not going to tell you about these bugs, but you will get logical errors, and logical errors are more serious. They are much more dangerous if you have them in your program than compile time errors, because compile time errors can be fixed. You cannot even run your program before you fix them, but logical errors usually in programs result in money loss or client loss and very, very serious problems. Just to give you an idea of this in real life, imagine the following situation. Let's say that you are writing a program for a bank and you decided to represent the account balance of some person with an integer number for whatever reason. So that person is very rich, so he ends up adding more and more and more money. So at one point, that value is going to overflow and all of a sudden he's going to be in negative. He's going to have negative amount of money, which is a big problem. But I believe that even bigger problem is if some person has very big debt. So his money is in minus and then he takes more debt and then all of a sudden his money underflows, so all of a sudden he has a lot of money, even though previously he was in debt. So I believe that is even bigger problem for a bank. So you should be very, very careful when you are deciding which data type to use. My suggestion is, if you suspect that the number is going to be either too big or too small, then please use more precise, bigger data types like double or decimal. And then there are even bigger data types that you can use. But for all of the calculations that you are using as a beginner, these data types should be enough. So decimal should be enough to store any number that you want, any number that you need for any application that you are making. So I believe that is going to be enough for this video. In the next video, we are going to continue talking about different types of operators, because there are many more operators. Also, if you want to learn about different data types that I mentioned, then I'm going to link that video in the description. Make sure to watch it. And then if you want to learn practical programming, if you want to learn how to build real applications, and if you want to get career-ready skills so that you can start a successful developer career, and if you want me to be your mentor in that process and to prepare you and to help you to achieve your goals, then enroll in my practical programming course. The link is going to be in the description, and currently there is even a special discount if you decide to enroll now. So with that being said, thank you very much for watching, and I am going to see you in some other video. Bye!